Okay, yeah. Well, I have presented on this topic before, but I've changed some of the slides a bit from previous feedback, and then we can have a discussion on some of these subtopics that I touch here. Basically, it's about very practical and low level and works with LabVIEW, of course, but in any situation where you do systems or software engineering. And I'm usually starting out by saying something like this: saving time and money by working smarter. And in this case, it's modularity. Because modularity tends to make your job easier. It tends to let you focus your mind and intellect and your ideas on what is actually the difficult parts of your task, making a piece of software, or making an application, or making a system of some kind, instead of having all this complexity to consider all the time. So in this case, save time and money on software development and maintenance of that software by working smarter with software modularity and automating some of your development tasks. So for those of you that don't know me, just really short, I founded GPower around 10 years ago, and am currently CTO of GPower. I've been working with LabVIEW for 25 years or thereabout, and have worked in many different programming languages. LabVIEW is a programming language I prefer nowadays, but I've done a lot with C++ and C and yeah, many different also embedded programming languages, Assembly and stuff like that. And at GPower, we do a lot of the types of projects that are quite common with LabVIEW, product testing and performance validation, and we do control and automation in general, and instrumentation for research, and so we do lab equipment and so on. So that's just really short about me. So today's topic is about LabVIEW, but the industry says we run into this a lot with our customers and potential customers, that LabVIEW is expensive. That's a very blanket statement. Why is it expensive? But LabVIEW is expensive, so it's difficult to sell LabVIEW. It's difficult to see an increase in LabVIEW use. It's actually in decrease, as far as I can tell. Because of this, that's one of the reasons that I the last couple of years has been very vocal about considering more of computer science when using LabVIEW, and it's not something highbrow, very difficult, or you can only do this if you have a university degree or something like that, a PhD. It is actually just being more structured when using LabVIEW that people that work with Python or .NET or C++ are already doing, or a lot of them are already doing. So the industry says LabVIEW is expensive. That leads to a conservative industry, in my experience. Conservative regarding LabVIEW, at least, but much of the industry that we service is conservative by nature, and when it comes to LabVIEW, it's even more so. That conservative industry leads to even more disadvantages for LabVIEW. So why is LabVIEW expensive? Well, it tends to, and I know there are differences to this. This is not everyone that runs into this the way I describe it. Maybe especially not with an audience like ours here, because we have been around, a lot of us, for many years. But in general, when you have LabVIEW projects, the coding time itself, I estimate it to take a long time, while people shuffle out Python programs or C++ program pretty quickly for in many situations at least. So coding time starts out as estimated to take weeks and months, and then there's a tendency to still overshoot that estimate. So it's expensive to have LabVIEW programs created in general. And then code quality is what I typically call not industrial grade all the time. It's not necessary all the time that it is industrial grade, but it's a tendency that it's a requirement more and more. So as long as the programmer follows the program, the guy or the girl works there, so you can just pick up, a keyboard when something goes wrong. You can put in a probe and look at what has happened and fix it on the spot. But if the programmer or the engineer is not available, which in an ever-changing and more advanced environment is more and more the case, that you are not there, and it's not expected that you follow along with the program, then you need industrial grade software, stuff that works, and when it does not work, it fails in an expected way and is easy and very quick to get working again. These things, when that is not in place with LabVIEW, is what the industry sees that LabVIEW is really difficult to deploy in their production environments, in their labs, and so on. So why does the conservative industry affect LabVIEW in a negative way in that case? Well, that the industry sees LabVIEW as expensive and difficult to get efficient and proficient programmers to actually do this in a solid way. That prevents these companies from investing further in improving the LabVIEW situation. So that just means that this downward spiral of how many people are available to do LabVIEW, efficiently, and to develop the infrastructure and our community regarding LabVIEW. How it prevents us from improving actually. So how do we improve that? Well, the easy way is just to say, well, be done quicker and create higher quality code. Sure, that's easy, right? But we are actually working pretty fast, and most of us are very efficient with programming and so on. So it's something inherent in the process that is typically slowing us down. So we can investigate why it's expensive. There are natural causes to this that I run into, and I think will probably be recognized out there by you guys. Starting from scratch, that's a lot of code, and yet we see a lot of projects that are starting from scratch. Sure, you might have some template code lying around. You might not start entirely from scratch, but you more or less do if you don't have a structured approach to how not to start from scratch each time, how to actually put some plans into effect around how you reuse stuff, and how you create templates, create new things from templates. Which copy should I reuse? Yeah, we have often several systems that look the same. They run almost the same version of the software, and if that software has been created initially by copying and then modifying on the deployment target on the runtime system, which in some cases with LabVIEW is even the complete development environment, then you have numerous, we see sometimes hundreds of copies of almost identical code or identical ways to approach a problem. Which copy do you use? And how do you feed back into your existing ecosystem of software improvements that you make to one or two other systems? I thought it worked. Yeah, if you don't know the state of the software you are reusing or building on top of, that's a very shaky tower to build a new project on. So that adds to the expense and delays you in the end. And also, if you look at the entire project, every time all the tasks, you list those in a backlog, and you start to develop these steps. You have a lot to look at. You have a lot from the start to estimate. So the hard parts, which are actually the problem you're trying to solve, gets mixed in task-wise with all the easy stuff. How to launch an application, how to close it, how to write a file, how to report an error, how to launch a UI, how to launch one of two different plugins if you suddenly need a plugin architecture. And that leaves too little focus on the hard parts. So if you have 10 tasks, you each estimate those as 10% of your total execution time to get this project done. Then you run into the hard part, that is actually an algorithm or some investigation or some R&D trying to get something fine-tuned or optimized. That is not 10% of the time. That is maybe 80% of the time, and that will delay your entire project. And then noise, not audible noise, but noise in information. The more software components you have in play when implementing something adds to the noise. So you miss stuff. You have to change focus a lot. Why does that result in bad quality code? If we can say that. Well, for starters, if you're pressed for time, the budget is already used up, and you, or at least your manager, might expect you to also be late. So you're pressed for time from the start. That is an unhealthy environment for good quality code. We can all do it, and it's a bit like perhaps the certifications. They are pressed for time. That's for a reason, to test some things. But in your everyday work, if you're pressed for time, that will have consequences, negative consequences. Reusing stuff when you're pressed for time that wasn't designed for what you're doing is not a good idea. If you pick something out of a prior project, you can definitely be sure that the thing you picked up was never designed with that in mind, that you're using it for now. So that will have consequences for your code quality, and also for your time spent. And then if you do everything as new code, even simple stuff, I can easily make this message transport. I can easily, write this file type or split this file format when it reaches 1 megabyte in size. So it will, instead of using something you have done and you have pressure tested that did this correctly and is continually improved. If you do this as new code because you can, and we can, then it's unproven code. We do make mistakes once in a while, and every time you do the same thing again, it's an opportunity to create new mistakes. They simply creep in to our code. Inconsistencies, when you are, for instance, multiple developers or multiple, at least, people involved, that creates inconsistencies. The more code you have working to work on, the more inconsistencies you run into. These inconsistencies are sometimes discovered late, and then you start with band-aids and fixing and workarounds because time is also running out. That results in bad quality code, or worse quality code than if you had more focus and less on your plate to do. And noise, again, disguises problems, maybe even bugs. A complex application is much harder to discover bugs in your natural development flow, and it's actually also more difficult to thoroughly test. So, how to more quickly make higher quality code then? There are a couple of good recommendations. We have seen, or I have experienced a lot with myself and my team, that there is a tendency to talk a lot about how is stuff supposed to be done, and then we do something else. So one of the best practices that I can offer is actually do it. It's not enough to know how or say the right words when you're going to lunch. You have to do it, and you have to do it every time. It's a hassle, and it's tough work, especially if you're pressed for time, but it will, when you find the balance of what to improve and what to just make as scratch code. If you do it every time, that will slowly improve your process. It will slowly improve your code base and your skills in knowing where to put the balance next time. So do it instead of just talking about it. There will not be a better time than today, because then tomorrow you will have the advantage of have done it today. So don't wait till tomorrow. And then do it right. Get all the way to done. Don't stop at 95% done. Complete it. If you run into a type definition that you need to refactor out of a library or change to accommodate something else, make that change. Make it complete to done, and maintain good coding practices along the way, because you will build your next steps on top of this. Don't postpone it. Don't wait with documentation or stuff like that, or selecting the right data type. It's like building the application on the last day. You will run into problems, and there are several things that you will never turn back to actually completing. So do it right, get to done immediately. And then design for reuse. Not everything, obviously, but things that can be reused, design it for reuse from the start. There are ways to do it. It can be done in steps. It doesn't have to be either or, but at least design it for reuse if you recognize something can be reused. Picking out an old project as a starting point is the worst kind of reuse, as I mentioned earlier. That was definitely never designed for what you're using it for now. So pulling stuff out of an old project, don't do that. And then do it consistently. Yeah.
Sorry, just on that last point about design for reuse, have you got any sort of specifics on that one? Because that's a really interesting one, and I've sort of not thought of it. Well, not heard that term before, and it kind of just sparked a thought that that's actually a really good sort of approach to get your mind into when you're designing and developing.
Yeah, it has to do with maintaining good coding practices for one thing. So APIs. Let's say that if you have a software component that has a public side and a private side, making the API usable and making it as a software component, what you are currently working on, is different from having it embedded into a monolith of an application. And an example could be an application that does something with, let's say, a protocol. It communicates with a device. Isolate that protocol and read and write capabilities and its data types and its parsing and so on into a separate library, a separate package. Mm-hmm. Then you have designed it for reuse. Maybe you're just using it for this application and you won't ever use it again. But that is a component that you can, and you probably will, maintain independently of the rest of the application. And now we can do it. So if you design for reuse, you are suddenly capable of sharing, let's say, the write capability or the read capability of that protocol with a third party when they ask for it, instead of having to carve it out of the application. And that requires maintaining good coding practices and also some of the tools that make it easy for you to create a new software component the way you like it to be created. That could just be, a template for the way you like a library to look, or it could be some wizard that creates an entire package for you, or something in between. But have it in mind, what is at a component that that this could be carved up into for to ease the maintenance of that.
Nice one.
And then do it consistently. So if you see yourself doing the same things a couple of times, see your team do it a couple of times, then consider at least moving that into a template. So we have a single place to improve on, and everybody can gain advantage from those improvements. And even make wizards that help you create stuff automatically. Do some things at least to do the actions that you want to repeat consistently. So save that file or that folder layout or that configuration for somebody else to use, and let your team know that it exists. If when you go from 0 to 1, that's a really big step in being able to reuse stuff, and then you have something to improve. If the alternative is just talking about it, then you can talk and talk and talk. You never get to the point where you feel you're ready to actually commit this to a template. Start with it. The really low-hanging fruit, basics, start with that, and you have something to improve. And one of the most important things in my mind is minimizing complexity. I call that noise in our work. Complexity is a lot of things. It could be the number of files. It could be names of stuff. It could be data types. It could be algorithms. How do you divide up your application? So complexity. And do you, for instance, implement everything now? Or do you implement a basis that you can implement everything on later on? Keep the noise down in your projects. It is one of the best ways to improve your execution speed and your improve your code quality, application quality. So, as I said, the future must pay for what the future needs. In other words. And then single responsibility as from the solid the solid practicalities, which are object-oriented set of terms, but single responsibility is one of those terms that, in my mind, can be used for all software, all systems, and can dive a bit into what I mean by single responsibility. It's a single role. So to really improve, if we could boil that down to reduce the amount of code on your plate for a given task. If you can reduce that, then you have a higher chance of success. So that's reuse to some extent, if possible. Be consistent. Do stuff just once instead of returning again and again. Automate where possible and reduce noise. Preparation, just a single slide for the next parts of how can this be done in practice, ideally. There are a couple of things. Packaging technology, not everything regarding reuse or software components is a software package, but packaging is a large part of it. And for many things that are actually based in computer science, I hear a lot of people when it becomes difficult, when it gets tough to do stuff, they think that's optional. Well, we can use packages if we want to. It could be an improvement, but we can also not use it. We can use libraries if we want to. We can consider namespaces if we want to. Source code control is optional. No, it's really not. You lose something by not doing this. And typically you will lose time. You will have lower code quality. So for some things, sure, scratch code, you're just testing something out, you delete it in a moment. You don't need unit tests. You don't maybe not even need source code control. But that is because your use case is different from something that goes into production in a moment. And even if you're the only programmer, the only developer on it, you might even be the end user of it. you will have value from these things. Then version numbering. It's important to have a strategy around version numbering. The numbering scheme I have shown here is semantic versioning. That's a standard, more or less, and we use that at GPower, where the major version number is a breaking change. So everything that has the same major version number is compatible. It's the same thing. It's just in different versions. And then you have minor and patch, which just signify different levels of changes. A functional change in minor and bug fixes in patch numbers. And then the build number can signify different things. We work with incrementing when we make a new build of a given version, and then resetting when we change the version. Then start again from zero, or actually from a different build number, because the build numbers themselves mean something, but that's a different thing. But so have some kind of version numbering scheme that helps you manage your software components, your packages later on. And then this again with single responsibility, which I will come back to in a moment, what that means. So just to highlight a bit of what do I mean by a software component. A software component could be a library, it could be a package. It's basically just some collection of software that has one role. It fulfills one role, and it should be quite easy to explain what that role is, or else you have probably put the divisions between your software components at the wrong place. So it has a single responsibility or a single role. It does one thing and it does it good. It's understandable and it's sealed. So understandable, so you don't run into trouble. Your users will be successful using your software component. You will be successful developing that software component and testing it. If it's not understandable, if it's fuzzy on the edges, if it's undecided, if it should have that functionality or this functionality, of this should be included or not, then you need to sit down and decide those things. That makes it usable for everybody. It makes it work as expected, and it's maintainable for the future. It's actually a big part of designing applications, designing software components, is making the stuff you do understandable. It also has to do with what do you call it, what names do you give inputs and outputs, and your entire software component. Is it a thing or does it do a thing, for instance? And then keep it sealed somehow. Depends on how sealed, what sealed means in different contexts. That's an implementation thing, but it must be self-contained. Sure, it can have dependencies, but it must be self-contained. It shouldn't have threads all over the place to other things that are private stuff and hidden and surprises. It should be compatible regarding the version scheme, version numbering scheme I talked about earlier. Therefore, it becomes replaceable, and because it's also understandable, it's a stable software component. You have a very focused determination of when it's a breaking change and when it's not. You can see it in the major version number. That's a software component. And if you do that, you have a surface on that software component. That surface is your public API. If anything on that changes, you have a breaking change. And then you have private implementation inside it. It doesn't have to be scoped to be set as private. That can have disadvantages as well, but it at least obvious where the private and public boundary is. If, for instance, a developer has access to some sub-VIs in a function palette or in QuickDrop, then that's a public API. If they don't, that's probably private implementation. And if you use that instead, if you're able to, because the scoping is not disallowing it, then you're on your own. So you can change the private implementation without it's a break-in change. So the single responsibility, it does change with scope, because you can you don't get a long way by saying, well, we're just writing TDMS files. That's the role of this software. It changes depending on the zoom level you have on your application. You know, can have a subroutine, a sub-VI, for instance, that does one thing. It's not the same thing that the API VI does. It calls a number of subroutines, but that function have to be a single function. And then you might have a package which is a collection of similar functions. But you have to have the thread running through it, that this is still a single role that this component at that level does. And then you have an application feature. This application feature might be file I/O. It might be some hardware driver. It might be UI. It might be a login, logout feature. And then you have the entire application. Well, this application is a word processor. This is a spreadsheet. And then you might have system components. This computer handles all the user access, and that computer handles all the hardware communication, for instance. And then you have a system. This system makes sure that we have, let's say, cool milk for the entire village. Well, that's single role. So ideally, when we have an application, if we're talking about software, that application tends to, for everything but the very, very smallest applications, tend to have a lot of source files. If we look deep down, it has a lot of source files. It might be 50, it might be 1500, but we use a lot of source files to get anything of decent amount of work done. That's a lot of noise if all that has to be in your project. If you take a copy of application A here to make an application B, then you have all these hundreds of files tagging along, and you make a few changes to that, and it's an entirely new project. You can't see the similarities anymore. So to reduce that code into something, I think I have a laser pointer here. You can reduce that code into some internal dependencies, as I spoke about earlier on your question, Chris, that you might have something that you actually make as a package just for this application even. It doesn't have to be a reuse package. It's just a component that has a single role that you can open up and develop and maintain and add features to and debug and test and adjust independently from the application. That could be some of the command protocol. This one could be an image analysis library that does some stuff, calculates some stuff on images from cameras, for instance, in your application. And this could be something that handles a specific file format. If you can segregate this into, isolate these components of these software source files basically into each their own package, then they don't make any noise when you're working with the application itself. You know it works, and if you have a problem with the command protocol, then you put your project on pause for a moment and open that project instead for that package. Fix your issues, add your features, adjust something, and then you have a new version of that package. You save that to source code control, and you install the new version of it, and then you reopen the project. And now you suddenly have new features, and you don't have to think about all the VIs, all the source files that are in this package anymore. That means you can focus very clearly on your application A, even with internal dependencies. If you then have an application B, you do the same with that. And if there are any similarities, well, then some of the internal dependencies from application A might be promoted to external dependencies that can suddenly be reused. They don't have to, but they could. And over time, you might have reuse components that makes you able to do more and more complex and higher quality projects with less effort. And you can trust that code because it has a lot of mileage on it contrary to copies of copies of copies, where it's always one-off code, even though it looks similar. Why do people not do this then? Yeah, that's the question. Really hard and time consuming to do it right. So we tend to not do it right. We tend to take shortcuts because the next new thing is more interesting to do. And once we reach something that pushes back on us, we walk around it and then just make it work for our purpose now and not for the future. And it is a fine balance when to do something for the future and not just for the current project. It's an incremental process. So package requirements. What do we need actually for these packages to be successful and reusable and help us? They need to be side-by-side installable. So we need to have a clear version strategy. We need to consider namespaces, disk locations, so major versions do not step on each other. You need to be able to install version 1 and version 2 of the same package side by side. And in most cases of package managers, you need to consider or implement a lot of that with the proper settings and package parameters. You need to have some sort of feature diversity. So you need to create different versions of a package. One version with debugging enabled and one without. Maybe in LabVIEW's case, with or without block diagrams or restricted access to block diagrams, perhaps. Some of the packages might have LabVIEW menu entries to the tools menu to help or to edit, and some might not because they are not running in the development environment. Same with palettes and same with unit tests. They might be included or might not be included. Then you need target diversity. Are you extending LabVIEW with this source code? Typically use via package manager for that. Is this just a shared library for somebody else to use? Or is it a runtime plugin that should be deployed someplace where the development system is not available? And that runtime plugin is typically a PPL or something similar. And for testing purposes and for development purposes, that PPL or that plugin or that component should exist both with and without development features. So you need a palette for the PPL instead of having to browse through it with the Explorer to find what VIs are exposed in the PPL and what of those are private and which are public and so on, with no documentation. So you need palettes in some cases, and you just need it installed in other cases as a plugin or as a component, a shared library. So target diversity from the same source, actually. And that's the next thing. It's ideal to have a single source and then automatically, or at least somehow, configure and build the different package output from that source. So it's just a configuration management issue rather than multiple sources that you need to maintain across all these different diversities that you need of the same component. Then there is sugarcoating. If you are doing this, then you might also like to automate it instead of doing stuff manually. You need maybe to modify documentation of your code automatically to stamp into the source code. What is it that you're seeing in front of you right now? Is that a debug enabled version, or is it a dependency only version, or is it a runtime version of what you have installed, a sub VI in a palette or in QuickDrop that you have on a block diagram? Which version of a given package with this name did this one come from? Instead of looking in your package manager to see what is actually installed and looking at your paths in context, help to see is it actually this one that is loading and so on. The VI itself should be able to tell you that, and at build time that can be stamped into the VI. And then you have other things like enhanced error handling. You can modify the license files if there are any, and probably also we need at least some sort of user customization sometimes. So we can build a package in one variety for one user and a different variety for a different user, and that has to show in the package. Highlighting of what this means. This side-by-side installability means, for instance, GPower package here, dictionary version 0, that's just a development version. Version 1 and version 2, those can all be installed at the same time, because if all your application or all your other components uses dictionary version 1, and you at one point in the future have a version 2, which has a new feature in it, it's a breaking change. So it's actually quite difficult to go from version, or it could be difficult to go from version 1 to version 2. It involves a lot of work, perhaps. Then if you have just a single component that needs this new feature from version 2, all your entire application is not forced to update to version 2 as well. They can do that if they have some value from it, or they cannot. And then you just depend on both these versions until they are on the same version. And then also the source code itself typically exists in some sort of development environment where the installed components are on the LabVIEW and program files, or they might be installed in custom folders on a runtime in a runtime environment. So to avoid cross-linking between the deployed code and the source code, we need some sort of management of the namespaces of the libraries for convenience. Else you suddenly link into VILib instead of your folder that you have checked out something from source code controller. That's very bad, and then typically gets discovered too late to avoid a lot of work. So, and then an example of automatic source code and palette documentation that can happen with if you have tools that do these steps for you. You can suddenly have added the yellow parts here of VI descriptions that gives you a couple of parameters of what is this kind of VI and where does it what does it belong to. Automatically calculation in this case of its error strategy. Same with palettes, which goes a bit away with QuickDrop. In practice, we have a package folder template that is actually the source code for all our components. It looks like this, and it does change slightly over time. We are on version 3 of the template, but that is managed in our tools as well. They just change slightly over time. There is always a library in a project. We have facilities for custom library errors, but that is just an option. It's something that we like. We have a special place for menu entries because that makes it easy for us to include and exclude stuff. There is a package configuration that makes it possible to have an API automate the actual use of the package template as well. And then there is a build configuration, and we have build source traceability. So this is the source that we see here. And in the builds folder, everything that is created, every configuration of a given build is copied from the source at that point. It is versioned and then configured. So we can, and then built, obviously, so we have the build output as well. For instance, an installer or a VI package. If there is a problem with the build output, we can go back and see exactly what went into that build. We don't have to recreate it somehow. We can see that is the source that went into the build. So we can investigate the links through it and see where did it go wrong, if there is something wrong, something that we didn't expect. And those builds are auto-created and configured at build time. So we also have a VI package build spec, and that is one of the things to use VI Package Manager, actually VI Package Builder. to build packages for via Package Manager. That is one of the things that keeps some people away from using it because it's quite complex. We have far more than 100 fields in VI Package Builder that needs to be configured correctly, and not just the source files, but the configuration itself to be able to successfully build with the correct names and versions and ending up in the correct install destinations. And that's just VI Package Manager. Then there is NI Package Manager as well. But we use VI Package Builder spec for, at the moment, actually just defining a palette. That's it. Everything else is automatically generated. And we have an API for that to automate creation and modification of VI Package build specs. So our tools use that API to modify for the different types of builds. This one didn't exist, so we had to make that as well. But that's part of making the tool change that enable us to get to that nirvana of doing stuff the same way every time. So in practice, we do it with a tool that we call VI Package Assistant, which can create new package, new version of a package, a new build. And the new build, for instance, has configurations of what type of build do you want it to create. And you can copy a package if you want to base something off an existing package. It supports one source with multiple build options. For LabVIEW, we can build debug and developer and dependency VI packages that install to the LabVIEW environment. So the difference between debug, developer, and dependency, for instance, is the palettes, is the unit test included, are debugging allowed, and so on. And we can we're working on, that's not completed yet, we're working on shared components. So the same also can build debug, developer, and plugin PPLs that are distributed within our package manager. We can do that manually today, and I've done that for 1.5 to 2 years now, and feel confident that we can now automate that. So we can build PPLs with palettes and PPLs without palettes, and have PPLs that depend on each other and so on, but from the same source as VI packages. Then we have a need for building with author and for different customers and open source license options with the same source as well. And we can signify in the build settings if this is a beta or if it's a release maturity. It will show in the descriptions and the build numbers. And all that, this package assistant, as I mentioned, uses this VIPB API to configure all these build spec fields custom for each type of build. And also the source files, obviously, that goes into it. And that includes automatic handling of unit tests. Some of the builds, if you select should it include tests or not, then the developer has pointed out it can also detect some of the tests, and you can add to that as a developer if you have folders of files or configurations that belong to the testing part of the package. So you can create a dependency package that has unit tests with it or without unit tests, for instance. It sets and does not set debug flags and so on. It includes palettes, sets passwords, or what doesn't, depending on your build spec, what you need to build. There are things like, for instance, setting passwords does not work if on your palette you have merge VIs, the VIs that drop their content instead of as a sub VI on your block diagram. So many of these scenarios, all the scenarios we have thought of and run into are taken care of by the tool. So even if you ask it to set passwords or the configuration, you don't ask it. That would be too many settings. That it would just look like LabVIEW options. But you select what type of package you want to build, and all those settings are set for you. So if you select a build setting that will enable password settings on your source files, that will skip obviously those source files that does not support a password because they are merge VIs in the palette, or because they are inline VIs, or because they are malleable VIs and stuff like that. So, as I say, have more fun and save money by working smarter, and that is, in our experience, that is where we need to be to actually solve our problems with LabVIEW. We need this level of automation to go from toying around with LabVIEW and doing something that we think works to be able to efficiently develop and deploy advanced systems with LabVIEW. And it's only possible if everybody's in on it. So both yourself, obviously, but your entire team and your leadership must understand why and how to do this. And you must actually do it. So that concludes the presentation of how to actually work more structured and smarter with LabVIEW on the source file level, I'd say.
That was great, Steen. Thank you very much for that. Really, really interesting to be listening to. I guess we'll open up for questions. I can see Chris Roebuck's dropped one in the chat there, Steen. I don't know whether you want to just read through that and respond to that one first of all, whilst other people think of any questions they might have.
Yeah. I see many software projects start out with good intentions to do it correctly, but when delivery is close or pressure is increased, then corners are cut right at the very end. Yes, this is so sad. Sure, we see that. One of the things that we talk about a lot is that we live in the real world. Everybody does. So everything that you guys see, we see that as well. And sometimes stuff happens. That's not ideal. But this is an improvement. We're talking about working towards the ideal. We call it tau. We're working towards that ideal. And if we, on average, work towards that ideal, it has been a good day. We might not be able to reach it in one go. We might not be able to go 100% in that direction all the time, but on average, we are moving in that direction. Then it has been an improvement on that work day rather than going the wrong direction or not deciding, at least. So it becomes more random. But sure, having these talks and knowing what you miss if you do a workaround, or if you skip a step, or do something suboptimal, is better than not knowing. So we know what we are saying no to when we hurry up and get stuff done. And sometimes the decision is easier to say, well, we need to take this hit and be finished tomorrow instead of be finished today. That costs us something, but it will cost us more not to do it correctly. So you can at least have that conversation if you are well versed into doing it the right way. But it is a decision on the day. What do you do? Yes, often the fastest way is the right way. It is. And Jörg says, where can we get all that good stuff? Yeah, as I actually said last time I presented on this, we are working on making all this available. Now we had a summer vacation that actually slowed me down a bit. So, but I'm one of the stops that have to be pulled from this. Our idea is to release a lot of our internal tools for free. Some of them might not be free, but most of them and many of them will be free and then available to improve our community over time. And also our VI package assistant, I expect that to be available. And I have said it before at the start of the year, but I hope it will be in 2022, this year. We'll probably release it. We have been waiting a bit on what happened with NI Package Manager, what happened with LabVIEW, what happened with JKI, Project Dragon, and so on. But we have decided to move ahead and continue as if nothing external happened, because those things also are delayed. So I hope to have something, a lot of this to share with you guys within this year. So, and you'll probably hear it somewhere if it becomes available.
That's awesome, Steve. Sounds really, really good. I think David's put a question in the chat about link to FPGA.
Oh, yes. It's something that we haven't solved completely. It's real-time and FPGA are actually quite difficult in LabVIEW projects because of many reasons, but especially because of the application builder API is not very automated on those targets. A lot of custom strings you need to know, ID strings and so on, to see what is the OS, for instance, on this target. So having support for real-time targets and FPGA code is difficult. It's not something that we have automated at the moment, but we assume that we will have some sort. We're forced to have some support for it, at least at some point in 2023, because we are developing a big internal product that will be able to run on not just Windows, but on several real-time targets as well. So we need to tackle this with our automated tools. Yes, but that's difficult. The packaging bits, creating a VI package that can be used for real-time and FPGA is not a problem. We can easily do that, and actually deselecting or actually selecting, separate compiled code from source helps with that, because then you won't have a source code change if you move that VI from your package from, let's say, a Windows target to a real-time or FPGA target. You would have that if you didn't separate source code from compiled code. So that helps.
Yeah, I think the biggest problem I've found is quite often when I'm using my FPGA, I will have code that can be used across projects, but so you'll have a module that does something specific on the FPGA, and then I end up taking that code and use it on another project. Mm-hmm. But in that FPGA, inevitably there is something specific, but that then means it's a specific build bit file that you're linking to, which then breaks all the FPGA references, and it's like the fundamental building block of the FPGA then ripples up through the code, and it makes it much harder to use these techniques. I was just wondering if anybody else has discovered that or had an amazing workaround that I could steal.
That's true, and there are some inefficiencies or bugs, or what you would call them, with, for instance, not the type specialization structure, but the conditional disabled structure, for instance, that does not truly separate, let's say, FPGA specific code from everything else. Those dependencies are dragged into the final file, even though you are deploying it to a target that has specified itself as an FPGA target, or the other way around, where you might have FPGA specific stuff that isn't running on or isn't able to run on Windows. So that makes it in some cases difficult to create one VI that is compatible with similar functionality on, let's say, Windows and Linux real-time and on FPGA, but has different implementations underneath. So we try to address this with NI when we run into stuff that isn't solvable with the type specialization structure or with the conditional disabled structure, because we would like this functionality to be, well, if you have an adder or a multiplier, something like that, we would like it to be multi-target compatible. But it's not always possible to do it.
Okay, thanks.
Nice one. I just had a thought, Steen. You mentioned about your sort of experience within the kind of C++ world. Do they have this in their community? Do they have all this kind of stuff wrapped up and nailed, or is it that they're also learning and developing this kind of thing already? And is there stuff that we can learn as a community from their community?
C++, the community, well, much of that is driven by the big companies like Microsoft and Kyle, for instance. So it's not my experience that there are a lot of community-driven efforts into this. It's probably I don't know, too conservative or too old an environment to have much of this. But the segregation into components, so that's for packages, right? Packages and you can download a lot of free stuff, but that's usually code snippets and stuff like that. That's not libraries. That's more rare. But the computer science part, if you could call it that, how to actually make a component with a single role and have these boundaries that very efficiently segregate private from public, even if you're not using OO, where you have that scoping built in. That has been around for C++ for all the time I have programmed it, more than 30 years.
Yeah.
So yeah, it's not as well automated. They make do with a lot less. That's one of the drawbacks of text-based programming. You need to remember a lot of scripting and stuff like that. But a lot of it is built into the development environments. You just need to know how to activate it.
Yeah. Cool.
Like auto completion, right? Does not necessarily pop up unless you do something right.
Right. Yeah. Awesome. Are there any other questions from anybody before we take a quick break between this one and Chris's presentation?
Anybody is welcome to drop me an email if you think I'm thinking of something tomorrow or another day and stuff like that. Well, I'll answer as far as I can reply to that.
Awesome. That's great. Thanks very much again, Steve. Really appreciate that.
Welcome.
Before we jump into a break, I need to tell everybody about something really awesome that's coming up in September, which hopefully everybody already knows about. But it's GDevCon number 3, 8th and 9th of September. We have a wait list for tickets because we sold out of our original allocation, and the team are working really, really hard to do everything we can to expand the venue size and capacity, which is looking really, really positive. So we're really hoping that will come off, and then the people on the wait